So hello everyone, this is Ankit, and today we are going to talk about kinetic theory of gases. And so dear students, welcome to the session. Hello Meghna, hello awesome Siddharth. So I hope all of you are doing well in your preparations. And now let's start with kinetic theory of gases. So dear students, the very important things in the chapter are, hello Braj Kishore, how are you? So in the very important things in the chapter are basically the RMS speed, okay, RMS speed, most probable speed, and average speed of the molecules. You should remember the formula of them, right? Hello Yamini, hello Divya, hello Minakshi, and hello Rohit, hello Rajesh. So good evening everyone, welcome to the session. Now let's see the first question, and with the first question I will tell you the related concept with this question. Now the first question is a mixture of 2 moles of helium gas. Its atomic mass is how much? It's 4 AMU. And 1 mole of argon gas, its atomic mass is 40 AMU. They are kept at 300 kelvins in a container. The ratio of RMS speeds. So students, what is the formula for RMS speed? Just Rajesh, that's very easy, right? What is VRMS? What is VRMS? VRMS, the formula for VRMS is actually equal to 3RT by capital M. That is the formula, right? So what is T here? T is the absolute temperature. You should remember this thing. It's the absolute temperature. Okay. Not the temperature in degrees Celsius. Be clear about this thing. And what is M? It's the molar mass. Okay. Or you can say atomic mass. If it's a monoatomic gas, it's atomic mass, right? So in this case, argon and helium gases are given. So their molar mass, that means it's 40 grams and 40 grams, 4 grams for helium. Okay. The molar mass of helium is actually 40 grams. And R is the gaseous constant. Okay. So dear students, let's see this thing. So what is the formula for VRMS? This is the formula for VRMS. So we have to find a ratio of RMS speeds. And we can understand that RMS speed is inversely proportional to M, square root of M, right? VRMS is proportional to under root of capital M. Okay. So we can understand from here that the atomic mass of helium gas is 4 AMU. So its molar mass will be 4 grams. And atomic mass of argon is 40 AMU. So its molar mass will be 40 grams. So we can say that let's do it in yellow color. VRMS, what we have to find, basically we have to find the ratio of VRMS for helium and argon, right? Helium and argon. So for helium gas and VRMS for argon, let's write them. So the ratio will be equal to square root of M of argon and M of helium, right? So we can easily say that's equal to, see, for argon the mass is 40 AMU, right? So it's square root of 40 over 4. and that's equal to under root of 10. And if you calculate the value, it's approximately about 3. So if you see the options, the closed value is 3.16. So the correct option for this question is 3.16. Okay, that's the thing. So that's a very easy question. See this chapter. So what? It doesn't depend upon the number of moles. Okay. They won't affect Meenakshi. Only 3RT by M is the formula for V Rms. So just apply the formula and you'll get the answer. Okay. Now let's see the other question. A vessel contains 1 mole of oxygen and molar mass is 32. At a temperature T, the pressure of the gas is P. An identical vessel containing 1 mole of the gas having molar mass equal to 4 at a temperature of 2T has a pressure of. What we have to find in this question, what we have to find, students? We have to find what pressure of the other gas. See, the questions that come, their language may be tricky, or they may actually confuse you, but this question is very easy. Okay, this question is very easy. You can understand that. Simple application of PV equal to nRT will work for this question. A student will think, sir, molar mass 32, oxygen gas, then you will, find, see, N is given. Simply apply PV is equal to nRT. So, given that absolute temperature is T, so let's take for oxygen gas. Let's talk about oxygen gas first. For oxygen gas, pressure is equal to small p and volume. See, vessel, see the same vessel is there. So vessel is same. So let's take volume to be V. Okay. And that will be same for both of them, right? So now let's take temperature to be T only. Similarly, for the second gas, now how many number of moles are there? The number of moles are 1 mole. Okay. So N is equal to 1. Similarly, for the other gas, for the second gas, P2 is unknown. Volume will be same and temperature will be also same, and number of moles are equal to 1. So simply apply PV equal to nRT for the two. You can easily get the value, right? P. Now, for the first one, small p into capital V is equal to 1. Now see, temperature is 2T. Right? For the second case, temperature is 2T. I'm sorry for that. It's 2T. So PV is equal to 1 into R into capital T. This is equation number 1. And for second one, it's P2 into V is equal to 1 into R into capital into 2T, right? So just divide them, you'll get the value. R and R get cancelled, V and V get cancelled. So we can easily say P2 is equal to twice of P. So that's a very easy question, right? So the correct answer is C, 2P. Okay. Now, let's see the other question. The average translational kinetic energy of oxygen molecules at a particular temperature is 0.048 electron volts, right? The translational kinetic energy of nitrogen having molar mass equal to 28 and the molecule, see, so we have to find the translational kinetic energy of nitrogen molecules in electron volts at the same temperature. So dear students, as you all know, what is the formula for average translational velocity? Let me tell you, average translational velocity. Okay. or translational kinetic energy of a gas molecule. So, translational kinetic energy. Okay, for gas molecules that we have to understand. So let's take one gas molecule. Okay, let's take one gas molecule. Let's say the mass of one gas molecule be m dash. Okay, so m dash into V Rms square is actually what? It's the average kinetic energy. Sorry, into half is the average kinetic energy. Okay. Yeah, this is 11th class chapter, Fatima. Oh, sorry, Farheen Fatima. So next thing. Now see, what is VRMS formula? Formula for VRMS is equal to square root of 3RT by capital M, where capital M is the molar mass of 1 mole. So we can say E is equal to 1 by 2 M dash into 3RT over capital M. A very amazing thing we will derive from here. Beta smasher, that's average. See, that's average velocity. Basically, we take RMS speed in calculation of average translation energy. Okay. So half M dash into 3RT by capital M. Okay. So what is M dash? M dash is the mass of one molecule. And what is capital M? Capital M is the mass of 1 mole. How many molecules are there in 1 mole? Tell me fastly. How many molecules are there in 1 mole? Fast, tell me fastly. The number of molecules in 1 mole. Write down fastly. I'm waiting. Very good. Equal to 6.0 10 to minus 23 for 23. Or you can say Na. Avogadro number. Right? So I can say capital M is equal to Na multiplied by M dash. Yes or no? M is equal to Na into small m dash. Yes or no? That's clear. Capital M is the molar mass. Mass of 1 mole is equal to Na multiplied by M dash. That's clear. So now substituting capital M to be Na by M dash, we easily get E is equal to how much? 1 by 2 into M dash multiplied by 3RT over Na into M dash. Now, dear students, you can easily see that M dash and M dash cancel out. So E, average kinetic energy, is equal to 1 by 2, or you can say 3 by 2 R by Na into capital T. What is R by Na? It's equal to Boltzmann constant. It's equal to Boltzmann constant. Okay. So E is equal to 3 by 2 into kBT. This is the average velocity, average kinetic energy for what you are saying? No, smasher, it's not a Boltzmann constant. I'm just deriving the average kinetic energy. So from this expression, do you see any mass here? Anything like mass in this expression? E is equal to 3 by 2 kBT. Is there any expression for mass? Nothing like mass here. So you can see that this is independent of mass. This is independent of mass. The average translational kinetic energy is independent of mass or molar mass. Okay. So it's same for all the gases. It depends upon temperature only. Yes. Yeah, you're right, Smasher. You're right. R by N is equal to Kb. You're right. So E is equal to 3 by 2 kBT. For same temperature, the translational kinetic energy will be same. And that doesn't depend upon the gas. Now read the question. You will get the answer in a fraction of seconds. Now see, the average translational kinetic energy of oxygen, its molar mass is this, and at a particular temperature is 0.0448 ev, the translational kinetic energy of N2 molecules. Okay, so that's clear to all of you now. E is equal to 3 by 2 kBt, right? E is equal to 3 by 2 kBt. So same temperature, kb is also same, so answer is C, as most of you have told. So I'm telling you, in this chapter, the questions are very easy. The nature of question are very easy, but the language, the language people are not able to understand. This is kinetic theory of gases, Jitanshu. Now let's see this question. The average translational energy and the RMS speed of the molecules and a sample of oxygen gas at 300 kelvins are 6.21 into 10 raised to minus 21 joules and 484 meter per second respectively. So have patience while reading the question. See the question, try to understand the things. They're not very difficult. They're very easy. I'm telling you. Very easy they are. The average translational kinetic energy. What is the formula for average translation energy? For one molecule, it's equal to 3 by 2, R 3 by 2 kBt. Okay. So here we're talking about 1 mole. Right? Now see, the average translation energy and the RMS speed of molecules in a sample of oxygen gas at 300 Kelvin are 6.21 into 10 to minus 21 joules and 484 meter per second respectively. The corresponding values at 600 Kelvin are nearly. The first thing that you should note that E is equal to how much? It's equal to 3 by 2 kBt. It's the average translation kinetic energy. Okay. And what is the formula for VRMS? VRMS is equal to under root of 3 RT by M, right? 3 RT by M. For the same gas, we can observe E is directly proportional to temperature and VRMS is directly proportional to under root of T, square root of T, right? So E is proportional to capital T and VRMS should be proportional to root T. Okay. So in that case, if the temperature is doubled, now see, initial temperature is 300 Kelvin. And when temperature is doubled, you can say E becomes doubled. Now see, from 600 Kelvin, so temperature is doubled. So E will also be doubled, right? So E new, or you can say E at 600 Kelvin will be how much? It will be equal to how much? It will be equal to twice of the given value. 2 into 6.21 into 10 raised to power minus 21 joules. So what is the answer? You can see it's 12.42 into 10 raised to power minus 21 joules. Wait a while. 12.42 into 10 raised to power minus 21 joules. Okay. Next thing, VRMS we have to find. Now there are two options. A and D contain the same thing. So what is the formula for VRMS? VRMS is proportional to root T. So new value of VRMS should be increased by root 2. So VRMS new at 600 Kelvin should be equal to root 2 times the given value. Root 2 times the given value. What is the given value? It's 484 meter per second. And its value is 1.414. It's less than 2, but sorry, it's less than 2 but greater than 1. So according to that, it should be the best and closest answer is D. So D is the correct answer. Okay, is it clear? So now let's see the other question. Now, the temperature of an ideal gas is increased from 120 Kelvin to 480 Kelvin. If at 120 Kelvin the RMS speed is V, at 480 Kelvin it becomes what? That you can understand that small v is equal to how much? It's equal to under root of 3r into 120 divided by capital M. So let's say for the other temperature, V RMS will be V1. Let's say it's V1. Okay. So that's equal to square root of 3r into 480 divided by capital M. Just divide them. So you get V by V1. V by V1 is equal to V by V1 is equal to, you can see, under root of 120 by 480, and that's equal to 1 by 4 square root, and that's easy to understand. V by V1 is equal to 1 by 2. This implies V1 is equal to twice of V. So that means the option B is correct option, right? So do you have an idea of degree of freedom, students? What do you mean degree of freedom? Degree of freedom, we can say the number of ways by which a gas molecule can attain kinetic energy, right? For a monatomic gas, see, the molecule is single, so it can attain energy by moving either in x-axis or y-axis or z-axis. So there are 3 degrees of freedom. There are 3 degrees of freedom for a monatomic gas, right? Similarly, for a diatomic gas, the degree of freedom becomes 5. Why 5? Because along with 3 translational degrees of freedom, it has 2 rotational ones. One along this axis and one along the axis that is perpendicular to the plane, this axis. So these should be added. At normal temperature, you should not include vibrational modes. At higher temperature, you can see, at higher temperature, both the molecules, they start vibrating. Okay, both the molecules, they start vibrating, so we have to add 2 more degrees of freedom, so it becomes 5 plus 2 equal to 7 at high temperature. Okay, is it clear? I've told the answer the bus too. Okay, students. So on the basis of degrees of freedom, we can find the average kinetic energy. Okay, average kinetic energy of molecule is equal to F by 2 into kBT. So if you want to find the translational kinetic energy, just add the translation degree of freedom. So 3 by 2 kBT for translation. Similarly, if you have to find a rotational one, just write 2 in place of F for diatomic gas. So you'll get that, right? Better they were from advanced measure. So student, thank you so much for being there, for attending the session. I hope you loved the session. You learned a lot. So to know more how meditation can boost your preparation for JEE 2009, see this link and share the information. So thank you so much, and I wish you all the best. To see you in the next session. Thank you so much, students.